Behind the Brewster Inn and the Wobbly Barn Gallery in Brewster, Massachusetts, Dan Amorello and his crew await the start of another day on the job. Hired by the Feeney Brothers, an underground utility service company out of Dorchester, Massachusetts, Dan Amorello Services has been contracted to reconstruct the utility trench. The trench spans a 2.5-mile section of Route 6A in the sleepy little Cape Cod town of Brewster, Massachusetts. This is the temporary condition of the road. As required by the state, the road has remained untouched for a period of 3 months. This time gap allowed for any additional settlement of the trench's gravel subsurface. The trench utility service performed by the Feeney Brothers involved replacing a steel gas main. Residing 3 feet under the surface of the pavement, the new gas main was backfilled with dense grade gravel and then compacted. A 3-inch temporary asphalt binder was then installed. Each project has its own set of challenges. These challenges must be addressed prior to the work as well as during the process. This current project's main challenges included traffic, business, crossovers, and materials. Traffic. With the assistance of Brewster and Harwich police departments, proper traffic management is crucial. Not only do the officers have a safety obligation to local traffic and commuters, they also have to manage the numerous and continuous arrival and departure of paving trucks and machinery. Business. Although it is the off-season for many of the businesses along the project route, it is necessary that the presence of this operation does not disrupt the normal year-round business traffic. And because tourist season is right around the corner, it is important that the work is finished in a timely fashion. Crossovers. Along the route there are 4 crossovers. Crossovers, as the name implies, are areas where the utility services cross from one lane to the adjacent lane. The milling and paving of crossover sections has to be carefully planned and executed to allow minimal interruption with the already disabled flow of traffic. Materials. Working in Cape Cod also means that acquiring paving materials is also a challenge. It is important that the daily material estimates and usage is precise, as well as scheduled accurately, to ensure proper delivery. Company safety compliance is always a vital aspect of every job. It is mandatory that each worker adheres to the specified safety attire, including hard hats, eye protection, work boots, gloves, and a high visibility vest. The safety standards are addressed every day prior to the day's work. Here, an employee from the Feeney Brothers explains that safety infractions could result in worker suspensions, terminations, or worse, project revocation. Following each safety meeting, employees sign their names, affirming their commitment and responsibility to all safety compliance. Before the machines start the milling process, a worker marks off areas on the road every 100 feet. These markers are a way to accurately gauge how much distance per ton of aggregate they are attaining. This is necessary in determining how much material per day they are using, as well as how many feet per day they are achieving. Guidelines are also marked upon the road to assist the milling machine's operator with his intended milling path. The project begins with milling out the existing temporary asphalt from the trench. The milling machine, a Workin 1000, uses a 3-foot 4-inch wide milling drum to bore down to the desired 7-inch depth. To avoid possible future erosion problems, this project calls for an extra 12 inches to be milled on each side of the original trench width. Therefore, in order to achieve the desired final milled width of 4 foot 6 inches, 2 passes of the milling machine are necessary. A worker on the ground has a variety of duties to perform, often simultaneously, to keep the job running fluidly. These duties include assisting the milling operator by properly aligning the machine with the spray-painted guides, keeping an eye out for road obstructions that may not be visible to the operator, and communicating via hand signals with the truck drivers to maintain a safe distance from the truck tailgate to the milling machine's conveyor. Keeping a safe working distance from the milling operation, workers busily sweep kick-off debris back into the trench while another worker loads larger debris into the bucket of a skid steer. Following this, workers use rakes, shovels, and trowels to level high areas in preparation for compaction. Certain sections along the road also contain areas commonly referred to as bump outs or bell holes. These excavated areas denote section joints within the pipeline where welding was performed. In these areas, skid steers and jackhammers once again prove their usefulness. Here, a 5-ton vibratory compactor makes multiple passes, compacting the area in preparation for the first layer of aggregate. A worker applies an asphalt adhesive, or tack, to the milled walls of the trench. This water-based bonding agent is used to cohere the new layer of asphalt aggregate to the older existing asphalt. This step is important due to the potential for future cracking at the seam if not properly bonded. This area of the trench is now ready for the first of 3 layers of asphalt. The next phase of the project involves paving over the milled trench to establish a permanent foundation. The first layer of aggregate is a 3-inch lift of 1.5-inch state black base. The 1.5-inch stones in this aggregate provide a stronger, more resilient foundation. Workers control the rate and flow of the hot mix as the driver eases down a stretch of the trench. A grader follows the truck, leveling off the mounds of aggregate with its blade. Behind the grader, workers use asphalt lutes and rakes to further level the aggregate. The 5-ton vibratory compactor makes a series of passes over the newly spread asphalt base. Here, a fully loaded triaxle dump truck further compacts the asphalt. Triaxle compaction, an old technique often overlooked or unknown by many paving companies, has benefits over simply employing the use of a steel drum roller. Unlike the rigidity of a steel drum roller, the rubber tires of the truck provide a flexible surface compaction. This extra give allows small voids within the aggregate to fill, allowing a more thorough compaction. The second layer of aggregate is a 2-inch lift of binder. Applied with a paver, the 3/4-inch stones in this aggregate provide a stable and level roadway, creating a smoother riding surface. 2 operators work this paver. The main operator steers, sets the paving depth and width, as well as communicates with the truck drivers, coordinating the addition of hot mix into the paver's hopper. The second operator manages the paving width and depth of the right side, ensuring that a level and properly dispensed amount of aggregate is achieved. Workers follow the paver, shoveling and scraping residual asphalt onto the newly paved area. A compactor immediately follows the workers, leveling the fresh asphalt with the existing roadway. Finally, a street sweeper picks up any residual dust and asphalt chunks, rendering a clean and drivable passage for vehicles free of paving debris. Once the entire 2.5 miles of the trench has been reconstructed, it is remilled in preparation for the final top coat of asphalt. Employing the use of a larger milling machine, the Work 2000, Dan Amorello and his crew mill a 10-foot wide path along the route of the trench. The powerful teeth of the milling machine remove the top 2 inches of asphalt, depositing the millings into dump trucks. Here, the milling machine operator uses a series of horn signals to communicate with the driver of the truck, relaying necessary truck instructions. Truck by truck, the millings are hauled off to a reclamation site to be recycled. The final application of top coat asphalt is a 2-day operation. While a worker continues to apply tack to the remaining length of the trench, other workers use a propane-fueled torch to heat the edge of the previous day's asphalt. This is performed in order to attain a properly bonded seam, avoiding future conditions such as cracks, heaves, or bulges due to an improper junction. After the asphalt has been heated thoroughly, it is scuffed with metal tines, creating a coarse surface allowing for a better union with the new asphalt mix.
The paver is a Volvo model PF6110. Driven by a 205 horsepower Cummins engine, it has a maximum paving width of 19 feet. The hopper has a holding capacity of nearly 14.5 tons, allowing this paver to pave at a practical rate of 400 tons per hour. The first truck of asphalt arrives, marking the start of the last day for Dan Amorello and his crew on the Cape. Load after load of asphalt topcoat are fed through the paver. While the top operator steers and controls the rate of flow of asphalt, 2 additional operators control the width and depth of each side. Numerous workers follow behind the paver. Using lutes and rakes, they level and maintain the edges of the newly formed road. Here, workers apply hot mix to low areas by the shovelful. A 10-ton vibratory compactor follows the paving production line. This compactor produces a rapid succession of pressure waves, which spread in all directions, mechanically increasing the density of the final layer of asphalt. Multiple passes are necessary to thoroughly compact the material in order to withstand the future rigors of this highly traveled roadway. 12 working days and roughly 4,000 tons of applied asphalt later, the repaired roadway is complete. With the assistance and patience of local police officers, businesses, residents, and daily commuters, Dan Amorello and his crew have completed their 2.5-mile trench reconstruction.